Hi, my name's Judd. I've made a series of Knight's Moves Sudokus, so I wanted to go over one of them to talk about some techniques you can use to solve a Knight's Move Sudoku. This puzzle is called Sir Aloysius of Arendia. Let's read the rules. Normal Sudoku rules apply. So that means in every row, in every column, and in every 3x3 box, the digits 1 through 9 must appear. Cells separated by a knight's move may not contain the same digit. So for example, if we set a 3 there, then normally I couldn't put a 3 in any of these because that's the same row or column or box. But knight's moves is how a knight moves in chess, which is 2 and 1. So if I go up 2 and across 1, a 3 cannot go there. And notice the tool tells us that that is illegal. So none of these squares are allowed to have a 3. So for the entire board, no digits will be a knight move away from the same digit. For each line segment, so there are 5 line segments here. Select 2 digits. That line is a sequence using only those digits. So for example, if I knew that this was a 4 and then that was a 7, then that means everything on this line may only be the digits 4 and 7. The gray square contains the only digit not on any line. So here we have one given color, which is gray, says that digit doesn't appear on any of the lines. White dots are consecutive, black dots are in a 2-to-1 ratio. So that means if this was a 6, then this could be a 5, or it could be a 7. Just has to be a digit next to 6. And similarly down here, if this was a 4, then this digit could be a 2, because it's 2 is twice 4, or 4 is twice 2, or it could be an 8, because 8 is twice 4. One of them just has to be 2 times the other. Alright, so let's talk about how we can go about solving this puzzle. First of all, you'll notice there are no given numbers, so that's going to make it difficult. But we are going to be able to learn relationships between numbers. So we might know that the number here also appears here, and here, and here, and it might appear here, and here. Well, not there, but... So we need some way of tracking that we know that a digit appears in all of these different spaces. So one way we can do this is through coloring. So in the tool, we can choose the bottom choice, which is colors, and then we can make all of those digits the same color. So that's what we're going to be doing in this puzzle. So for this line here, it has 2 different numbers on it. I am going to arbitrarily assign this the number green. And then this digit is on the same line, but it's in the same box, so it can't be green, so I'm arbitrarily going to give it the color blue. Now what we've just learned is all of these digits here are green or blue. We have a different line, which is going to have a different number. Well, we know it has green on it. Can't have blue on it because that would make this blue, and then there'd be 2 blues in this box. So I'm going to arbitrarily assign it the color pink. There we go. We have, these are going to be green and pink digits. We have a new line here with 1 given. I'm going to make this orange. And then what color can these be? Well, they can be orange, but we didn't know whether this was green or pink, so we're not sure what else is on this line. So we're going to label them with all the choices. Now notice, these colors represent a digit, so in the final grid, the green might be 3s. Well, if I have a 3 here, that means I can't have a 3 here. So green in this column means this can't be green. We can remove green from there. Alright, so that's our start. We need a break-in. the break-in is how do you get started and moving forward with this puzzle? What's the tricky bit you need to figure out? Probably the most difficult part of this puzzle is deciding what to do next. So the question we have is, can all three of these rows have a green digit in them? And the answer is no. Well, how do we know that? Well, we have to try it. So if all of these have a green digit, then we're saying that this column is made up of green and orange. So this would have to be a green digit. Now, if we set that to a green digit, that's going to change a lot of things in our puzzle. So for example, this is in the same box as this digit. Well, this is green, this can't be green, so we're going to make that pink. This green sees this, that can't be green anymore, that's blue. This blue sees this, this can't be blue anymore, that sees green, this green sees this, that can't be green, that becomes pink. Notice we have two pinks here. So where is the pink in row 7? Well, it can't be in any of these squares because there's already a pink in the box. It can't be any of these squares because pink's in the box, so it's in one of these squares. But this pink sees that because it's in the same column, and it sees that because it's a knight's move away. So pink must be here. Well, if pink's there, that means pink can't be here. If green's here, that means green can't be here. We have blue, now we have two blues. That means blue must be down here. Well, this is already pink, it can't be blue. This blue sees this square, so this is the only place that blue can go. And we have just reached a contradiction. Well, why is that? Well, we have a blue here and a blue here, so we're saying blue must appear in this bottom row. Well, gray doesn't appear on any line, so it can't be blue. This can't be blue because it sees that square through knight's move. So we're saying that that square is blue. But similarly, we have green here, which says green must appear in this column. Except for we have a green here, which says it can't be here, and it can't be here. So this square must simultaneously be green and blue, which is two different numbers, so that's never going to work. So we have proved that green cannot appear on all three lines. So what we're going to do is we're just going to undo from our starting assumption, and we're going to say this can't be green. Now we're going to do the same exact step, except for now we're not going to reach a contradiction. So if this is pink, that can't be pink. This is green, this can't be green. This is blue, that can't be blue. This is green, this one can't be green. We have a line here. We've determined that our third line is going to be pink and orange. So there are no pinks. It's only pink and orange. There can't be greens on this line. So I'm going to remove greens from here. Okay, looks like we have done the easy pieces. So what we're going to do is what we did the first time. We're just going to pick two colors that line up, and we're going to mark where that color can be in other boxes. So for example, I have a blue here and a blue here, which means a blue must appear in one of these three squares. Except for there's a blue here, so it can't be there. And this blue sees that through knight's move, so that becomes blue. If that's blue, then that can't be blue. If that's green, then this can't be green. If that's pink, then this can't be pink. Alright, that was a good run. Let's keep doing it. Orange plus orange means there's an orange down here. This square sees that one through knight's move, so one of those two squares is orange. What about green plus green? Means there's a green in one of those squares. But I got a green here. That sees that by the row, that by knight's move. So this can't be pink. This must be our green. Where else do we want to look? Blue plus blue means there must be a blue up here. This blue sees this square, so blue is in one of those two squares. How about pink? Pink plus pink means pink must be here. This square sees that, so we're left with that. That must be pink. Pink plus pink means there must be a pink here. This sees that, so that must be pink. How about pink in this box? This pink says nothing in this column. This pink says nothing in this row. So pink must be here, but there's a pink here which sees that through Knight's move, so pink goes into those two squares. So now we have a pink in column 1, a pink in column 2. We must need a pink in column 3 that appears here. This pink says no pink there. And then there is a very common set of idioms for Knight's moves. This is one right here. Notice that this square sees this square by row and this square by Knight's move. Well, one of these two digits must be pink and one of them must be orange. If I make this pink, that says pink can't be in either of those two squares. So that's not allowed to be pink. We'll remove that, which makes this the pink square, which means that's not pink, that's not orange. This pink sees that, that's not pink. That green sees that, that's not green. And we are off. All right, what we want to do is we want to have all 4 colors defined in every single one of our squares. So we have blue, pink, and green here. Let's do some orange. Orange here and here means it must be here. This one sees that, so it's in one of those two squares. In this box, orange sees that, orange sees that. These two are already colored, which means orange is going to be in one of those two squares. Well, now we have it in that row, we have it in that row, so here, orange must be in one of those two. But let's go back to our rules. The gray square contains the only digit not on any line. All right, so we have green and blue. That's 2 colors. Then we added pink to green. That's 3 colors. We added orange to pink. That's 4 colors. I've got 9 colors. I've used 4 of them. I have to use 4 more colors. So what that means is when I choose the 2 colors, the 2 digits for this line and the 2 digits from this line, they have to be 2 new colors that aren't orange, green, pink, or blue. So that we've used 8 colors and the 9th color is the one that's on the gray square. Because the gray square contains the only digit not on any line. So I have to have 8 digits on the line. So that means this is not allowed to be an orange square. We'll remove that. That becomes orange. This sees this through Knight's move. That can't be orange. Means that's orange. Orange plus orange means there's an orange down here. But again, it can't be on the line. So orange becomes there. This orange takes out those. This orange takes out those. Both of them see that through Knight's move. So orange goes into one of those squares. I think we have orange in every one of our boxes. How about blue? Blue plus blue means there is a blue here. What am I missing? Oh, I didn't mean to change this. This was always blue. This wasn't flash blue. That's what I'm missing. All right, blue plus blue means there's a blue here, but this sees this one, so that's blue. Blue plus blue means there's a blue here. Through Knight's move, it sees that one, so there's a blue there. So I've got all the blues defined. I've got all the oranges. I've got not all the pinks. This pink says there's no pink in that column. This pink says there's no pink in that column. This pink sees that through Knight's move. This pink sees that through Knight's move. Pink must go in the middle, which means that's not pink. That is pink. All of the pinks are completely done. How about greens? We don't have all the greens. Green plus green means there's a green here. This is seen through Knight's move, so it's in one of 2 spots. And again, I wasn't supposed to change the flashing here. There we go. Green plus green means there's a green here. This one takes that out, so there's a green in one of those two spots. And finally, this box is not very well defined at all. This green says not here. This green says not here, which means green is in one of 4 positions in box 3. And now we have defined, we have all 4 colors in every box. Pinks, blues, greens, and oranges. So we're kind of stuck. So we need to use some new technique. All right, in this puzzle, we're given these dots. These dots are consecutive, so we know that orange is next to pink when we put numbers in. If orange was 3, then pink would be 2 or 4. So let's consider this square. What if I make this orange? Then we're saying orange is next to blue. But here we're also saying orange is next to pink. Okay, well that's fine. Orange 3 can be next to 2 and 4. So orange can be next to 2 different digits. That's fine. But we have an orange on a dot up here as well. So if orange is next to pink and blue, that means this digit must be pink or blue. Well, pink's here and blue's here, so that's can't be right. So what we've learned is this can't be orange. So let's change that to orange. This orange sees that orange. That's not orange anymore. That becomes orange. This orange sees that. That's not orange anymore. This becomes orange. Well, that's going to do a lot because green is in one of 2 squares. This has just become orange, so this must be our green square. And green doesn't go up here anymore. And this is about as far as we can go with our 4 colors. So what do we do next? Well, we have to assign 9 different colors. Let's start on the next one. So we know that this is 2 new digits. We're going to start here because these see each other. So I'm going to just make this one arbitrarily red and this one arbitrarily yellow. Then we know that these are red and yellow. All right, where does red go in box number 7? Well, red is not blue. It's not pink, orange, or green. It can't go in the same row. So red's in one of 2 squares. But we said that we have to use 8 different digits, 8 different colors on the lines. So red can't be on this line. This has to be 2 new colors. So red goes exactly in one spot. Then red has to go here. Well, this red sees that through Knight's Move. This red sees that through Knight's Move. So red must go exactly there. What about yellow? Yellow can't go there because it's in the same row. Can't go there because it can't be on the line. So yellow is in 2 spots, which means we have a yellow in row 7, a yellow in row 8. We need a yellow down here. It's not allowed to go on the line, which means yellow goes exactly there. Let's assign some new colors. I'm going to say that's dark green and that's dark blue. These 2 new colors have to appear in box number 9. Well, dark blue sees that square, so dark blue must be there. Dark green must be there. We got 1 box completely full. Dark blue plus dark blue means dark blue must be in the middle row this time. Dark green sees that square, so that becomes dark green. And all of a sudden we have 8 things here. What's missing? Well, that's this color we were given. So we're going to use gray here. This is the digit that doesn't appear on any line. And then here we said that was yellow. And the other digit it goes with is gray. And we don't know what order they go in. So we're just going to leave them as a color pair for right now. Now our goal is to fill in the whole rest of the box with colors. We've done a good job. We got 2 boxes that are completely full. Let's keep going. Well, the farther you are away from the givens, the harder time you're going to have. Like if you pencil mark this, it's going to be, 5 different colors. You won't be able to tell. So what we're going to do is we're going to just move from the bottom to the top. This digit is on a line, so we know that it is either dark blue or dark green. This digit is on a line. We know it's either red or yellow. What about the rest of this row? Well, we have pink, orange, blue, and green, the 4 starting digits we already did. So this is one of the 5 new ones. It's gray, red, yellow, pink, or green. Now, can we improve that at all? Well, we can improve that a lot. Look at this square. This square sees yellow right above it, or right below it, so this can't be yellow. Whoops, wrong yellow color. This square, red, sees this, so that can't be red. But this also sees this by Knight's move, so that can't be red. This gray sees that, so that can't be gray. And this dark blue sees that, so that can't be dark blue. That has become our dark green square. So we take dark green out of the rest of these. And all of a sudden that's become our dark blue square. So we take dark blue out of the rest of those. Can we do better? Well, this square, it's in the same column as yellow. This can't be yellow. And this red sees that through Knight's move. That becomes gray. That's not gray, so it's yellow. That's not yellow, so it's red. And we're done with row number 6. What about this box? We're missing 2 colors. One of them is dark blue. Dark blue sees that square, so that has become dark blue. And the other color we're missing is gray, so we'll fill that in. Let's do another row. What are we missing here? Well, we have the 2 new, we have gray, but otherwise we need the other 4 new colors, which were red, yellow, dark green, and dark blue. Well, dark blue's over here, so those can't be dark blue. This red sees that square and that square. And notice, so I can remove red. Whoops, don't remove it from there. This red sees that red, so I can remove red. So all of a sudden, this has become our red square. Can we do better? Well, this square sees this green, so that can't be dark green. This square sees that green, so that can't be dark green. So this has become our dark green. And we have a dark blue yellow pair, which we can't resolve at this point. Because if we look, you pick out the squares that are Knight's moves away, you look on the rows, you see any dark blues, you see any yellows? No, so we just keep moving on. This box is missing what? It's missing yellow and gray, which we can't resolve. However, notice now we have a yellow-gray pair, so we have 8 colors defined in this column. So what's the last one we're missing? It is dark green. If we do these 2, we're missing a dark green, and what else? A red. Can we solve that? Yes. This dark green sees that dark green, so that becomes red. That becomes dark green. Let's keep going. We have a column. We have 7 colors defined. What is missing? Looks like we are missing dark blue and yellow. We can't resolve that. This column has 7 colors. What are we missing? We are missing gray and looks like dark green. Put those in. Well, we filled a dark green in here, so that solves that. That can't be dark green. That's gray, so that becomes the dark green. Let's do this. It's a little more complicated. We still have the light blue and the light green original colors that we haven't discerned yet. What else? We're missing a red. So those are 3 different values, and we don't have an answer yet. This looks like a good column. We have 7. This is light blue, one of our original colors, and red. Alright, but this red sees that, so that's not red. So that becomes red. That red sees that, so that's not red. So that's not light blue. This light blue sees that light blue, so that's not light blue. That's become light blue. And all of a sudden, we have solved many of our original colors. The only ones we have are light green left. And I don't think we can solve those yet. The reds do not see that. The light greens don't see that. All right, how about this column? We're obviously missing yellow and dark blue. And what else? It looks like dark green. Dark green means that's not there, so this must be the dark green square. We have a yellow-blue pair again. This is our worst column. We have light green, we have yellow and blue, and something else is missing. What else? Yellow and gray. We're missing gray. Can we solve those? Does not appear that we can do that yet. Light blue, yellow, gray, dark blue. All right, let's continue. This column is missing yellow and gray and dark blue again. Can definitely tell what our problem colors are. And this is missing again light gray, gray, yellow, and in this case, what is our last, and red. All right, this red sees that, so that can't be red, which means that is our red square. That's going to help solve over here. That's not red. There we go. And we are left with, this light green solved that light green problem, so this has become our light green. We're done with the originals. Now, if you start looking, we're in a problem here. Pick a square, look in all the rows, the columns. Mostly look in the knight's moves. Are there any grays? Are there any yellows? Are there any blues that will help us to determine what this square can be? And the answer is no. So here's another very common thing you're going to have to do with knight move puzzles. Consider these two squares. This is a yellow and gray combo. But then this square here, sees this square because it's in the same column, but this also sees this square because it's a knight's move away. So if I make this yellow, that means neither of those can be yellow. Same thing with gray. So this square can't be yellow or gray because it would make this box illegal. So this has become our dark blue square, which means this is the dark blue square, and that's the dark blue square. We can take dark blue out of all of those. This yellow sees that. That's not yellow, so that's dark blue. That's not dark blue. So we solved all of our dark blue, and that's given us yellows. So now we can go and finish the puzzle. Yellow sees this. Not. That's not yellow. That's not gray. That's not yellow. That's not gray. That's not yellow. And we have completely colored the puzzle, which was our goal. Alright, so what happens next? That's not the solve. Well, now we can start to use these consecutive circles, dots. So in order to do that, I am going to turn on a new tool. We're going to have a little word pad up here. Alright, so what do we notice here? We notice that light blue is next to red. Okay, well, coming down here, light blue is also next to yellow. So yellow must appear. What else? We have yellow and orange are next to each other. So Front of yellow is orange. And when I say in front, we don't know if orange is higher or lower. We're just trying to put them in an order and then figure out the order later. Where else can we look? Here we have an orange and a pink combo, which means that pink appears next to orange. Pink appears next to gray. Oh no, I've lost which ones we've used. I think it's those. Pink is next to gray. What else can help us? Oh, gray is next to dark green. Dark green. And what else? We have one final dot. Red is next to dark blue. So now I have a sequence of 1, 2, 3, 4, 5, 6, 7, 8 different digits. I don't know what order they go in, but I know that pink is next to gray and orange. Alright, well, notice we're missing a digit. The digit we're missing is light green. So if these are all in a row, then that means light green must be an extreme digit. So it's either a 1 or a 9, because if it was a 5, that would prevent something else from being next to something else. So we're going to make this a 1 or a 9. Well, this is on a 2-to-1 ratio dot. So if we make this 9, then this would have to be a 4.5 or an 18, which obviously doesn't work. So we've just learned that light green is a 1. And then we can just use the dots to fill in the rest of this puzzle. Twice 1 is 2. 2 is consecutive with 3. 3 is consecutive with 4. 4 is consecutive with 5. 5 is consecutive with 6. 6, 7, 7, 8, 8, 9. And finally, this gray is slightly different color than those grays, so we have to fill it in manually. That's a 3 in the corner. And that is how you solve Sir Aloysius of Arendia.